Welcome to the project demonstration of hybrid power generation system using vertical axis wind turbine as well as solar along with grid. So these three sources are used to charge our battery. So the battery ratings are 12 volts, 2 amps battery pack we are using. So in this battery pack that we can see the two sub battery packs are connected in parallel. So each sub battery pack consists of 3 4 volt 1 amp batteries are in series. So we'll get 12 volt 1 amp from the battery pack 1 and from the sub battery pack 2 12 volt 1 amp. These two are in parallel, so we'll get 12 volts 2 amp DC output. So once the battery is fully charged, we can utilize that power for the microcontroller purpose as well as for the inverter purpose. So the inverter is nothing but will convert the 12 volts DC to 230 volts AC, and that will be utilized by this load. And the microcontrollers continuously monitoring the voltage from the wind power, and that will be displayed in terms of kilometer per hour wind speed and calculated by the microcontroller and displayed on the 16:2 LCD screen. So on the 16:2 LCD screen, we have interfaced that to the PIC microcontroller, that is PIC 16F72 microcontroller, which will read the input from this speed sensor, and we need to connect the wind at this slot, and this is for the charging slots. Same from the solar also, we are going to place the S here, and these two along with this one, these three are the charging circuits to charge our 12 volt 2 amp battery pack. So whenever the wind and solar is not available, in order to charge a battery, by using this grid supply, means the household supply 230 volts, directly giving that to the transformer, so we can charge a battery. There we can see the light indication on the charging circuits. Same with solar panel. So now let us see the execution. Connect the S at this S slots and W. So there we need to provide the parallel outputs. One is for the charging circuits, W is for the wind, and another is for this sensor to measure the speed of the wind. So after made the connection successfully done, so from the A0 pin we are going to read the data, and this is the main on off switch for the microcontroller to measure the speed and display on the LCD screen. So welcome message displayed, and thereafter it will display the speed. So the speed is 0 km/h, and this is for the inverter for utilization of the charged voltage from this battery to the AC load. So this will convert the 12 volts DC to 12 volts AC power supply directly. So now let us see the wind speed by rotating that. So it will work for the clockwise, as we can see the right. Okay. Here coming to this mechanism, there we can see the two gears. So there is gear ratio is 2.5 to 1:1 ratio. So when we are rotating this one rotation, 1:2.5 rotation will be increased. So there we can see the two gear ratio, the spark gears, one bigger gear ratio and a smaller gear ratio. So when this one rotates in one rotation, so 2.5 rotations will be happen and the dynamo section. Coming to the dynamo, there we are using the 12 volts 20 watts dynamo, and coming to the solar panel also 12 volts 20 watts of solar panel power will be generated from here. So when we are charging the battery only from the transformer or only from the wind or only from the solar panel, the battery will get fully charged in a duration of 6 hours minimum, 8 hours maximum. If 3 are available at a time, we can charge a battery in a span of 2 hours only, because of we are providing 60 watts of power from these three sources. So the charging time also will be decreases based on the availability power from these three sources. Right.